In 1957, the launch of the world's first satellite by the Soviet Union ushered in a Cold War crisis that came to be known as the race for space.
Recognizing the head start obtained by the Soviets with their large rocket engines, which gives them many months of lead time, and recognizing the likelihood that they will exploit this lead for some time to come in still more impressive successes, we nevertheless are required to make new efforts on our own. For while we cannot guarantee that we shall one day be first, we can guarantee that any failure to make this effort will make us last.
To overcome the Soviet lead, President John Kennedy openly declared the finish line to be the moon. Before sending humans, the U.S. strategy called for first launching robotic spacecraft, a job assigned to NASA's Jet Propulsion Laboratory.
Now we know we're doing something really important, and we better do it right, and quickly.
There was no book. We had to figure them all out as we went along. And of course, in that environment, you're going to make some mistakes.
JPL's ambition was to explore the planets. But to the lab's surprise, even crash landing a spacecraft on the moon would prove a humbling experience.
We were on a new journey, and nobody really knew where it was going to lead to.
Destination Moon. Beginnings of the space age. Next. In October of 1957, the Soviet Union shocked the world with the launch of the first Earth-orbiting satellite, Sputnik. America's response, a satellite called Vanguard, was also a surprising and spectacular event. Vanguard would be only one in a long string of setbacks for the United States space program. On a visit to the U.S. in 1959, Soviet Premier Nikita Khrushchev made sure to underscore the disparity between the two nations.
A successful moon rocket heralded Khrushchev's arrival in America, a scientific feat heavily capitalized on by red propaganda. It gave solid foundation to Khrushchev's boasts of Soviet achievement.
America's hopes for competing in the race for the heavens rested with its newly formed space agency, the National Aeronautics and Space Administration. NASA was given an assortment of technical facilities scattered across the country. One of them was the Jet Propulsion Laboratory in Pasadena, California.
There was about 500 employees. Maybe half of that was engineers and scientists. Procurement was one guy. Now it's a whole division of people. Parking is a big problem now. In those days, parking was no problem. Everybody drove on lab through the main gate here. Park wherever you want.
Of all the groups NASA inherited, JPL was a part. This research center was then, like today, managed and staffed by employees of one of the world's most renowned engineering universities, the California Institute of Technology. JPLers were accustomed to a tradition of independence. From JPL's perspective, NASA was a newcomer with no portfolio. In contrast, JPL had built missiles and the first successful U.S. satellite, Explorer 1. Already a place filled with confident engineers, this achievement had further bolstered JPL's self-esteem.
I think JPL in the late 50s, there was a real swagger. They felt that they were the best at what they did. They had the inherited condescension towards government scientists, and they felt that they should be able to run their own show. Basically, they thought, give us the money, and we'll give you a product here at the end, and don't bother us in the meantime.
JPL was led by William Pickering. A New Zealander by birth, Pickering came to Caltech to study electrical engineering and went on to become the laboratory's director. When NASA asked Pickering his ideas for the nation's robotic space program, he responded with an ambitious plan that called for JPL flying an armada of spacecraft to the moon and nearby planets.
Before the conference, we talk with Dr. William H. Pickering, director of JPL. In matter-of-fact terms, he introduces the coming greatest adventure of man, a search for life on other worlds.
The long-range purpose of unmanned exploration of the planets is the development of technology which will lead to eventual manned exploration. Scientifically, our objective is to assist in answering two basic questions. What, if any, life forms exist on the planets, and how has the solar system been formed?
NASA executives, who saw the moon as the priority, were shocked by Pickering's aspirations to reach so fast for the planets. But the JPL director held steadfast to targeting planets while still responding to NASA's insistence to first reach the moon. In the race for space, Pickering pointed out that the moon had already been lost to the Soviets. America's only hope to win, he argued, was to compete on a larger playing field: the entire solar system. Whether the destination was the moon or the planets, no one was going to go anywhere without a reliable rocket. For both its human and robotic programs, U.S. plans called for modifying military missiles, but they were having problems of their own. Lacking a powerful enough rocket to reach a planet, JPL had no choice but to throttle back its expectations and first target the moon.
We were given the assignment as the NASA Center for Deep Space Exploration. Nobody else had that role. Our assignment was to come up with a spacecraft that could go to the moon. I led the design team for that, and that was pretty great stuff. We didn't know what we were doing, and there was nobody around that could tell us. We were inventing stuff.
Come fly away, leave your troubles behind, journey far away.
The strategy called for first building a spacecraft that could obtain close-up images of the moon before crashing onto the lunar surface. These spacecraft, called Rangers, were to be designed and built at JPL.
Let's fly, come fly.
A second type of spacecraft would visit the nearby planets Venus and Mars. Meanwhile, JPL was to select and manage the work of an industrial contractor that would build a third kind of spacecraft, one capable of soft landing on the moon. What seemed the least challenging of these three spacecraft were the moon-crashing Rangers.
You don't need a high-gain antenna or solar panels to go to the moon. You just have batteries and an antenna that big. Fine, they get us there. You see, so our whole Ranger philosophy was planetary precursor.
In charge of the Rangers was Jim Burke. He was a Caltech graduate, a former naval aviator who had learned his trade at JPL, building missiles for the Army.
I wasn't afraid of the job. I thought it would be fun. Well, turned out a little different.
Burke was well-liked for his infectious enthusiasm and informal style, a demeanor that gave little hint of the enormous pressure he was now under.
Pressure is always part of any project management job, but young and frisky and full of pep and armed with a good degree from a good university and a lot of very smart friends, who minds a little pressure?
Let's fly away, wanna be with you.
Burke stressed keeping to a schedule. Celestial mechanics, he knew, waited for no one, nor would the Russians. But Burke soon became caught up in a conflict between schedule and science. He wanted to learn how to fly his spacecraft before tacking on major science cargoes. NASA countered there was no point in just hitting the moon. That had already been done by the Soviets.
My version of it, then and now, was, look, this whole thing is ridiculous. They shouldn't even be thinking of putting other things on the spacecraft until we get one that really works.
Next, to Burke's dismay, Ranger was saddled with a surprise requirement by NASA. Responding to concerns by scientists that Ranger could transport microorganisms that could contaminate the lunar surface, the spacecraft, NASA demanded, would have to be sterilized. But how? The answer, to the horror of JPL engineers, was to bake the spacecraft at temperatures above 250 degrees Fahrenheit for more than 24 hours. What that would do to an unproven spacecraft was anyone's guess.
What we did was to reduce our chances of success substantially.
And there continued to be a problem entirely out of the team's power to control or fix: the rockets that would get Ranger off the ground. The first stage rocket was a converted Air Force intercontinental ballistic missile called the Atlas. It would launch Ranger into Earth orbit. The second stage, called Agena, was to kick the spacecraft out of Earth orbit and onto the moon. But it was behind schedule and hampered by technical problems.
Everybody understood that it was a high-risk mission, and that's why they gave us 2 Atlas Agenas to launch with spacecraft whose only function was to see if we could make them work.
On the morning of August 23, 1961, Ranger 1 lifted off from Cape Canaveral, Florida. All went well for the first 90 minutes. Then telemetry showed that something had gone wrong with the second stage Agena rocket.
The tracking stations were all focused on the part of the sky where the spacecraft was expected to be, and there's no signal. And still no signal, and still no signal. And finally somebody had the brilliant idea, why don't we turn the antennas around and point them in the other direction? And sure enough, there it was.
Though this first mission was intended only to circle the Earth, it failed to reach a proper orbit. Designed to fly on continuous solar power, Ranger 1 instead passed into darkness and a loss of orientation every 90 minutes. Each time the confused spacecraft emerged from the darkness, it would reacquire the sun and fire its engines to regain a proper position.
So it looked as if the spacecraft were doing exactly what it was supposed to do and would have worked just fine if it had only had the chance. And we were in the middle of this, in the middle of the night, when Dr. Pickering walks in, trying to find out what's going on, and we're all telling him what's going on. This guy is listening to what some 23-year-old kid is telling him about this thing that's going on out in space. And it was sort of, hey, if you're there talking, the assumption is you know what you're talking about. And if you don't know, the only right answer is, I don't know.
Within 24 hours, Ranger's fuel was exhausted. Ranger 1 languished 7 days before being incinerated as it re-entered the atmosphere over the Gulf of Mexico. 12 weeks later, Ranger 2 met the same fiery fate when once again the second stage Agena rocket failed to properly fire.
It was almost a relief that Ranger 2 only lasted a day, because we'd been there before. We'd done that. We didn't want to see that again. So it was discouraging.
The first 2 Rangers were test flights in Earth orbit. The stakes were much higher for Ranger 3. This time the destination was the moon. Yet for a third time, a rocket failure doomed the mission.
Again, we had the launch vehicle problem, In this case, it wasn't that the launch vehicle failed to give us a boost, it gave us too big a boost.
But not all that had gone wrong could be blamed on the rocket. Ranger 3's central computer failed, causing the spacecraft to lose its orientation. Instead of pictures of the lunar surface, the spacecraft beamed back a blank screen. On the fourth try, the Atlas and Agena rockets finally worked. But as soon as Ranger 4 separated from the Agena, the spacecraft's master clock in the central computer stopped working. Without a brain, no further commands could be executed. The unresponsive Ranger crashed into the far side of the moon, but provided no images and no science.
It just flat failed. And that was kind of a setback. That was a blow.
Some in the American media, desperate for anything positive to say, picked up on the point that for the first time an American spacecraft had at least actually hit the moon. JPL continued to plow ahead with its fifth attempt.
Ranger 5 flight preparations are continuing at the checkout facility at Cape Canaveral. Certain modifications have been made on this craft to possibly eliminate the unexplained failure which occurred in Ranger 4.
For a second time, the rockets worked, setting the Ranger on a course to collide with the moon. But yet again, the spacecraft malfunctioned. Ground controllers could only watch as electrical power was lost, followed by the sickening realization that Ranger 5 was yet another failed mission.
Born to lose, I've lived my life in vain.
The once confident JPL engineers were now deeply shaken. Crash landing on the moon had been the least of their ambitions.
Many of us had to go back and testify in front of Congress. Special committees set up to check on us. That was not a pleasant time.
I think NASA was of a frame of mind that said maybe we ought to cancel this contract. But we persuaded them, give us a year before Ranger 6 and we'll try and get all the bugs out of this thing.
What, the humiliated JPLers asked themselves, had caused so many things to go wrong? Had all the science experiments, many tacked on late, overwhelmed the engineers? Had sterilization fried the electronics?
You could find specific problems, what caused them to fail at the time, and you could still go in and fix those. But when you have a series of failures, there's more than just that. And my own belief is that the people who were in charge of it at that time were giving too much priority to schedule and doing it as quick as possible, as opposed to doing it in a more careful, deliberate fashion to make sure it worked.
Changes were demanded by NASA, and heads began to roll. One of them was Ranger Project Manager Jim Burke.
It always hurts if you get fired. That's not fun. But in my case, I sort of thought getting fired was deserved, in part because of the sterilization business, but also some other things that I knew I had done wrong. But as far as being dejected, downcast, suicidal, all of those thoughts, nothing of the kind. That's the kind of emotional state I was in. I was much more sort of anticipating a future success and thinking to myself, how are we going to get there?
Even in the midst of the Ranger crisis, JPL was hard at work on other missions. In the summer of 1962, final preparations were underway for the first U.S. attempt to reach Earth's nearest planetary neighbor. Venus provided the best chance for a spacecraft to reach its destination. The spacecraft, though, was not what JPL engineers had first planned on sending.
Mariner was to be a new design, really a second-generation spacecraft that was specifically designed to go to Mars and to Venus. But the design was not far enough along for it to be used for the Venus 62 opportunity. So we actually took a Ranger, we called them Mariner 1 and Mariner 2, the first two Mariner missions to Venus, but they were Ranger spacecraft. Not many people know that.
Mariner R is a hybrid design using features of both the Mariner A and the Ranger spacecraft.
The key experiments are a microwave radiometer and an infrared radiometer.
JPL was also beginning to understand the importance of underscoring with the public the risks involved in space exploration. This film, called Clouds of Venus, was a mixture of actual events and recreations, with all the characters, some real, some fictional, emphasizing how difficult the Mariner mission would be.
This spacecraft must operate unattended for nearly 4 months.
Mariner 1 blasted off the launch pad on July 22, 1962. At first, all went according to plan, as the Atlas rocket accelerated through Mach 1, 2, and 3. But then, the Atlas began fishtailing and veering off course.
We're not on trajectory. This is range safety. Stand by.
That reads good.
Mariner was only seconds away from separating from the errant rocket when the range safety officer had no choice but to give the destruct command.
Destruct command. Repeat, destruct command.
This one apparently blew up.
Analysis showed that the cause of the rocket failure was a software error. A single misplaced symbol of code had resulted in the loss of the first U.S. spacecraft destined for another planet.
It was offset a little bit by our knowledge that we had another one to go. You know, maybe we could resurrect things here. And that, of course, we put all the energies into that.
Now I'll call on Bob Parks, our planetary program director. Bob?
Thank you. Gentlemen, Mariner 2 operations are all unscheduled. Now, obviously, this is a high-risk mission. Even if the Mariner launching is completely successful, we have many critical flight problems to face.
With the software problem corrected, Mariner 2 lifted off and began its 3.5-month journey to Venus. An early critical event was deploying the solar panels to convert sunlight into electrical energy.
Numbers came out, when you analyzed them, that there was a 1% chance of success in a sense that all these components would work.
The first 14 critical operations are complete. We wait now for sun acquisition.
Sunlock, we're in.
Like the man said, we're in. Maybe.
The Earth sensor, when we first turned it on up there and locked on the Earth, it was working fine, but it was working at a much lower level sensitivity than we had designed into it. As we got farther and farther away from Earth, we knew that if that sensitivity stayed like that, we wouldn't be able to stay on locked on the Earth all the way to the planet Venus.
As Mariner 2 raced away from Earth, the signal strength continued to lower. If the signal could not be boosted, all communications would soon cease. There would be no science return, only another mission failure.
And just a few days before it would have stopped being able to track, the signal strength jumped up to where we designed it. And we were able to do the rest of the mission just fine with that Earth tracker.
Another pressing issue was keeping Mariner 2 on a proper course.
Tuesday afternoon, it is decided to go ahead with the trajectory correction. Goldstone engineers send roll, pitch, and velocity commands to the spacecraft. The motor is fired and shuts off on time. Now we must wait. New tracking data will determine if the flight path has been corrected. 2 hours later, newsmen gather at JPL.
The mid-course maneuver was successfully accomplished. The spacecraft has reacquired the sun.
Have we gone past the point of any further correction? Are we now going for broke?
Yeah, that is correct. We can make no further correction. We're either right now or else. We still have approximately 100 days to go before we arrive at Venus.
For 100 days, JPLers worked around the clock, steadying what was becoming an ever more troublesome spacecraft. One of the members of the team was a 22-year-old flight controller who was both a pioneer in exploring the planets and venturing into the male-dominated world of engineering.
I found myself not only involved in the planning of the operations, but the actual conduct of the operations. And before I knew it, I was 22, and I had been assigned as one of several flight controllers on Mariner 2. I was good at that work. I was good at operations work. I had a shift of my own, usually midnight to 8 in the morning. Women didn't have opportunities like that, and there were some number of people who were pretty sure that they shouldn't. That flight was probably the largest experience in growing up a young woman could have. I got through it, and I was very proud of myself for getting through it. But from then on, everything seemed easier.
In December, Mariner 2 was closing in fast on Venus, but it was in a precarious state. Portions of the spacecraft were overheating. Several critical telemetry sensors had stopped working altogether. It was taking all the energy the solar panels could produce to keep the spacecraft functioning. On December 14th, Mariner 2 made its closest approach to Venus, flying by at a distance of 20,000 miles. In Pasadena, a steady stream of science data came pouring back as audible sounds throughout mission control. Scientists were elated, although most of the results were more confirmations than new discoveries. There was no onboard camera, so there were no pictures. There was also no sign of a magnetic field or a radiation belt like Earth's. For a planet considered Earth's twin for its size and near proximity, Venus revealed itself to be a hellish world filled with carbon dioxide, and where surface temperatures are hot enough to melt lead. If the science return was modest, the public reaction to the technical achievement was enormous. For the first time, the United States could point to its first in the race for space. It is a proud time for the U.S., Time magazine proclaimed. No achievement by a Russian cosmonaut or U.S. astronaut, no experiment made by any of the myriad other satellites that have been shot aloft has taught man nearly so much as the improbable voyage of Mariner 2. William Pickering found himself featured on the cover of Time. Pasadena honored the JPL director by naming him Grand Marshal of the Tournament of Roses Parade. NASA arranged for Pickering and his management team to meet John Kennedy at the White House. In the Oval Office, they presented the president with a model of the spacecraft. Mariner 2 likely saved Pickering his job, and JPL its leadership role in exploring the solar system. 20 days after passing Venus, Mariner 2 transmitted half an hour of telemetry and then went silent. Today, the spacecraft is a mute piece of metal that endlessly circles the sun. But inside the spacecraft's thermal blanket is a small American flag, secretly placed aboard against official wishes, as a patriotic act to honor the very first in space for the United States. The success of Mariner 2 and a reconstituted Ranger team buoyed hopes that the next attempt to hit the moon would be different than the previous 5 attempts. The new Ranger project manager was Bud Schirmeyer. His resume was identical to that of his predecessor, Jim Burke. Schirmeyer was also a Caltech graduate and a former naval aviator. The two men were also close friends, which helped to reformulate the project.
I know it was a big job, but I don't know, I guess that I just said, okay, let's jump in and do it. By golly, we're going to make this thing successful.
The worrisome requirement of sterilizing the spacecraft, once deemed of vital concern, was abandoned. To the dismay of scientists, all science experiments were tossed off except one, sending back live television pictures of higher quality than could be seen through earthbound telescopes.
There were a lot of scientists that said, pictures, that's not science. That's just public information. Over the years, that attitude has changed so markedly, and so much information has been obtained just from the photographs that it has been an outstanding scientific instrument.
When Ranger 6 reached the launch pad in January 1964, it could claim the distinction of being the world's most tested spacecraft. The destination was a candidate landing area for the Apollo astronauts. Ranger missions were originally intended to help select these sites, but running so far behind schedule, the best Ranger could now do was to provide close-up images of where the Apollo mission planners had already decided they were going to go. The Ranger 6 launch went perfectly. The only anomaly came when telemetry showed that the spacecraft's television camera had inexplicably turned itself on for 67 seconds. But just as quickly, the camera had turned itself back off.
Everybody sort of scratched their head and said, what was that? And put it on the back burner and didn't worry about it.
Other than this one minor glitch, all systems were normal. Navigators confirmed that Ranger 6 was right on target to hit the moon in the early hours of February 1st, 1964. A guarded Pickering declared to the press that he was cautiously optimistic.
It was, I think, a 66-hour flight to the moon. But everything was going great. We're going to have a success here. I drove in with my van with all of the champagne bottles in the wash tub with ice in them, all set to celebrate.
As the spacecraft neared the moon, JPL's auditorium was packed with reporters. They listened as Mission Control announced the final minutes of Ranger 6. 18 minutes before lunar impact, the spacecraft directed its 2 television cameras to turn on and warm up.
We should now start getting video. And all through this agonizing last round, he said, there's no video, no video, no video.
118, holding steady. No video.
Roger.
No video.
Roger.
Still no video.
Roger.
It was just heartbreaking. We got all the way to the moon, and we got no pictures. Everything worked flawlessly, we thought, up till then.
The unthinkable, the unbearable, the unbelievable had occurred. After the Atlas missile, the Agena second stage, and Ranger itself had for the first time flown a picture-perfect mission, the television camera, the sole goal of the revamped Ranger mission, had failed to turn on.
That was really disastrous to us all.
A shell-shocked Pickering arose from the console and declared he never wanted to go through such an experience ever again.
It was a very sad experience for the lab, and probably the low point in the lab's history.
You know, we were terribly disappointed because we had stopped and regrouped, as they say, but had missed a design flaw in the system. And we got bit by it.
You have 6 Rangers which fail. With each failure, the pressure on JPL became more intense, and after number 6, this was really a catastrophe.
The program came to a halt. There was a congressional investigation and a number of investigations by NASA headquarters.
I had no fear that the lab was going to fall apart. It was quite the opposite. Everybody pulled together, basically, what can I do to help?
We were young kids and anxious to figure out what went wrong and fix it. The demoralizing part was the pressure that NASA put on JPL, but that's the business we're in.
6 months after the debacle of Ranger 6, JPL was ready to try once more. The television system that had failed was completely reworked by the television contractor and JPL. It had required working 3 shifts a day, 7 days a week.
The next one, 7, was a severe strain on everybody because it had to work. And if it hadn't worked, there's no telling what JPL would have been like or what would have happened to JPL. It was a sobering experience.
Launch through the 66-hour cruise was a textbook flight. 3 days after liftoff, JPL's auditorium was once again filled beyond capacity with people and tension.
Magnetic tape recorders were started at 130700 Zulu at both Pioneer and Echo sites. We are anticipating F-channel warm-up at 130719.
Coming up on impact, minus 18 minutes. Channel F still in warm-up.
We are 1 minute to full channel power. All magnetic and kinescope recorders are gold. This is Goldstone TV control. F-channel is still in TV warm-up. We are anticipating turn-on momentarily. We are 5 seconds from full power. We have full power on F-channel.
Roger.
Power on F-channel. All kinescope recorders are recording. All magnetic tape recorders are recording. Video is very strong. Video is very clean. This is Goldstone TV control. Preliminary photographic analysis of the video indicates we have good signal strength from the moon. We definitely are able to see craters. We have excellent video. 10 seconds to impact. Video still good. Excellent signal strength. 3, 2, 1. Impact has occurred at 132550 Zulu. All video data was excellent right up to impact. All cameras were functioning. Transmitters were functioning properly. This is Goldstone TV control.
Oh, roger.
When impact occurred, the auditorium erupted in a great cheer. People shook hands and hugged one another. Some wept. One hard-nosed engineer likened the event to a spiritual experience.
There was joy all around, as you can imagine, after the trials and tribulations of getting to that point.
There was not a dry eye in that room. Failure was nothing to be afraid of, you learned. But success was such an emotionally overwhelming situation that it let loose.
Some people had smuggled in some champagne, and champagne bottles were opened. There was a great celebration.
But in the middle of the festive atmosphere, somebody handed me a little note and said, "Dr. Pickering wants to see you." What did he want to see me about? I went up to his office and he handed me a photo. Said, "Here, Jim." It was the first high-resolution picture. That was good.
Later in the day, after Ranger 7's crash landing, the most detailed pictures of the moon ever taken were presented to an anxious press.
This is a great day for science, and this is a great day for the United States. What has been achieved today is truly remarkable. We have made progress in resolution of lunar detail, not by a factor 10, nor by a factor 100, but by a factor of 1,000.
Next, Pickering and NASA officials rushed to Washington to brief President Lyndon Johnson. 2 more Rangers would fly to the moon. Though scientists were pleased with the images, they did little to resolve questions about Earth's orbiting companion. Rangers' pictures are like mirrors, one scientist declared, and everyone sees their own theories reflected in them. Of all the questions NASA wanted answered, the most important was knowing what the surface would be like for Apollo astronauts. Was it solid? Would it support the weight of an astronaut, let alone their lander? Or would layers of dust act like lunar quicksand and swallow them whole? NASA had hoped the answers would come from Surveyor. This was JPL's first experience in overseeing on behalf of NASA the work of an aerospace company, and the process had not gone smoothly. The Surveyor program had started in 1960 as a very hands-off contract arrangement. That was how NASA wanted it. In fact, NASA hoped JPL would adopt more to the industry's ways of working. But the contractor, Hughes Aerospace, was struggling, for good reasons. Surveyor was far more technically challenging than the Rangers. This spacecraft not only had to soft land on the moon, it had to do so autonomously. It was also expected to send back images and science data from the lunar surface, not for a day, but for weeks. By 1964, the project was over its budget by a factor of 5 and far behind in its schedule. Surveyor was in deep trouble. By then, NASA realized it was the contractor who actually needed to learn from JPL's experiences with Ranger and Mariner. JPL was instructed to make Surveyor its highest priority.
And he said, we've got to put people in residence at Hughes for an extended period of time, probably 2 or 3 years. That was a difficult, trying period because we were growing up at the same time that Hughes was growing up. And we didn't always mesh. A trying time.
JPL responded by assigning hundreds of its engineers to the project. They flooded into Hughes, elbowing their way into the minutiae of the project.
After kind of an initial adjustment period, I think everybody turned to and began to recognize the importance of Surveyor, and certainly the importance that NASA placed on Surveyor as being the precursor for Apollo. It just couldn't afford to fail.
Standing 10 feet high, the Surveyors weighed over 2,000 pounds. The first one was a stripped-down model carrying only a television camera. Surveyor 1's testing program had gone so poorly that the flight's primary objective was only to operate through its mid-course maneuver. It was not even expected to hit the moon, let alone soft land.
In those days, we launched a lot of them because we expected failure. The Surveyor 1 was deemed by Hughes Aircraft and by NASA headquarters on the day of the launch as being kind of the engineering test model. So if it met the majority of its objectives, they would be pretty happy. But it's pretty obvious they had a higher expectation of failure.
We are now well into the countdown at approximately 3 minutes before liftoff. All systems are reported in excellent condition at this time.
Pressurization. Go, Atlas. Go, Centaur. Atlas autopilot. Go. Centaur autopilot. Go. Launch director. Go.
Yes, this looks good. Doppler readout is nominal. Chamber pressure looks good. Liftoff was at 7:41 Pacific Daylight Time on an azimuth of 102 degrees. The aerodynamic shroud is off and Grand Bahama is tracking. Liftoff plus 4 minutes and 3 seconds. As shown by the animated diagrams in the monitor, the Atlas Centaur separation has occurred. Centaur cutoff. Surveyor is injected on its lunar flight path. Separation. And report that the landing legs are extended. The Surveyor is now in space.
"63 hours after launch, Surveyor 1 was only 1,000 miles away from the moon, with the speed increasing as the moon's gravitational attraction beckoned.
Vernier ignition. Retro is now firing. Ignition looks stable. Falling steadily. 63,000 feet, 3,500 miles an hour. Now at 30,000 feet. Retro burnout confirmed.
The vehicle is supposed to enter a fixed rate of descent. So that happens.
28,000 feet, 425 feet per second, 24,000 feet. Falling steadily. Down to 12,000 feet. 10,000, all signals normal. Surveyor reported in excellent condition, all signals good. 1,000 foot mark. 800 feet. 600. 400 feet. 200 feet. 100 feet, 13 feet per second speed.
At a certain distance above the surface, the engines are all supposed to shut off. And then it's supposed to drop to the surface. And the engines all shut off. And you could hear a pin drop. It worked. We're down. It's still transmitting.
Surveyor 1 touched down at 5 miles per hour, a mere 1 second off the intended landing time. For the first time, an American spacecraft had achieved a soft landing on another celestial body. Surveyor 1 operated for 6 weeks, surprising engineers by surviving a bitter cold lunar night. In all, the sturdy lander sent back more than 11,000 images before its batteries ceased to work. Surveyor 1 now rests where it landed in July 1966, telling us of its presence by casting a silent but long shadow on the lunar surface. 6 more surveyors were launched over the next 2 years, providing a treasure trove of science about the moon. Although 2 of the missions would fail, the increasing ratio of success to failure demonstrated that JPL was clearly learning from its past mistakes. And NASA had the answer to its question. The lunar surface was solid and suitable for landing by the Apollo astronauts.
It's one small step for man, one giant leap for mankind.
When Neil Armstrong first set foot on the moon on July 20th, 1969, JPL could point with pride that they had helped to create the pathway, at least in providing the evidence that a soft landing by the Apollo astronauts was possible.
And it gave engineers in NASA a lot of confidence about, that we wouldn't sink into the dust.
Alan Bean was the 4th person to walk on the moon. Assigned to Apollo 12, Bean and Mission Commander Pete Conrad's task was to improve on the navigation of Apollo 11. The first mission to land on the moon had missed its intended landing site by 4 miles.
They said, look, we've got to demonstrate and develop capability to land exactly where we want to, and that's the job they gave us.
Apollo 12's assignment was to attempt, in essence, a pinpoint landing.
And they said, well, how are we going to know if we really landed there? Well, let's pick some place that's got something there that doesn't look like all the rest of the craters on the moon.
The answer was to use a landmark, but not a natural landmark. They chose Surveyor 3.
The interesting thing to me was they didn't know where Surveyor 3 had landed either.
Okay, we're out of 19,000 feet. I got some kind of a horizon out there. I got some craters too, but I don't know where I am yet. Okay. I'm trying to cheat and look out there. I think I see my crater. Hey, baby. I'm not sure. P64, Pete. P64. Hey, there it is. There it is. Son of a gun, right down the middle of the road. Outstanding. 42 degrees, Pete. Hey, it's targeted right from the center of the crater. Look out there. I can't believe it. Amazing. Fantastic.
Oh, we found that crater, and we were going to land on the near edge of it. There was too many blocky rocks there, so we overflew it and then landed on the far right corner. And we still didn't know that Surveyor 3 was there. We said, we're at the right crater. I hope Surveyor 3 is here.
We're headed down the ladder. Okay, wait, let me get the old camera over there. Okay. Man, that may have been a small one for Neil, but that's a long one for me. Boy, that sun's bright. That's just like somebody shining a spotlight in your hand. Boy, you'll never believe it. That's what I see sitting on the side of the crater. The old surveyor, huh? The old surveyor, yes, sir. Does that look neat? It can't be any further than 600 feet from here.
It was just starting to come into light. The solar panels were just illuminated, and there it was sitting right where it was supposed to be. So it felt really good.
Apollo 12's mission included bringing back to Earth parts of Surveyor 3, but the spacecraft had landed in what appeared to be a deep crater.
So we began to talk about how we're going to get down there. This is too steep. We're liable to slip down in the crater and can't get out. We don't have any ropes with us. We were concerned about it. When we got out the next day and looked over there, the sun was on that slope, and then it was obvious that it was about 13 degrees and we wouldn't have a problem. We were concerned about one thing, whether or not the Surveyor, which was down inside this crater, would it continue to slip, and it would slip down on us or something.
Now you're closer than 15. Don't go any closer. Yeah, maybe I better back up and add it, boy. Okay, now let me get that footpad. That's a beautiful shot there. Now look, you can see which way it came in. See the way this gear pad's Doug in over there. Dug up dirt and you're still sitting there. Yeah. Go ahead, you get yourself in the photo too. Hey, big smile. Okay. Okay, Al, we're ready to start getting a TV camera. Okay.
The television camera was of special interest because of the number of different components it contained. Scientists and engineers wanted to know what 2.5 years of exposure on the moon had done to them.
I better be careful. I'm going to get dust on it.
There was, there was optics in there, there was wire, there was lubrication, all different kinds of metals. So that's why this thing seemed important to bring back. It was a lot more difficult to cut those stanchions for Pete. So he fooled with it a while and rotated them and cut through. We weren't going to be denied.
Okay, 2 more tubes on that TV camera and that baby's ours. That's ours. That's baby's. We got her. Beautiful.
Then we looked around for other things that we could get, and of course the scoop was right there. They didn't ask us to bring it back, but it looked pretty tempting.
Let's get the scoop while we're at it. Didn't think you were going to leave without a scoop, did you? No.
When parts of Surveyor were brought back to Earth, scientists made what seemed an astounding discovery. They found inside the camera a common bacterium, Streptococcus mitis. Had this bacteria survived a trip to the moon and back? Or had it been introduced in the lab?
We found out over the years since that time that life is very tenacious and comes up even at the bottom of the ocean, out of volcanic vents. There's life down there. So I think this is just an example of life from Earth going to the moon and staying there.
Whether or not Surveyor brought bacteria back to the Earth remains an unsolved mystery. But the assertion raised in a new and serious way the question of life existing elsewhere. In the years since first touching the moon, Mars has become a prime candidate as a place where microbial life might have once, or might still, exist. And it was Mars where NASA and JPL next set its sights. And perhaps one day in a future not as distant as we might think, another astronaut will again bend down and touch a robotic explorer, one that once roamed the surface of the red planet.